Hello and welcome to our What's New session with SAP Datasphere. My name is Klaus-Peter Sauer, and together with my colleagues on the product management team, we will be updating you on the latest features and functions we delivered in Q3 this year. So, looking at the agenda, we will be covering updates with new features in the data integration and data modeling area, but also other components of the product. At the end, I will give you an outlook on what we plan to deliver in Q4 and the next couple of quarters. So let's get started with a new feature in the configuration area. This next new feature is about enabling the multi-availability zones for the SAP Datasphere customer HANA Cloud runtime as a self-service functionality in the backend of Datasphere. So it's basically in the configuration area of Datasphere, and enabling it creates a synchronous replica of the underlying HANA Cloud runtime in a different availability zone of the same data center region. So that provides resiliency against infrastructure failure of a single availability zone and thus improving the availability and disaster recovery. This has been a ticket-based process before and now is enabled via this self-service flag. And if we look at this in the system, it's really just a simple checkbox here, which you see on the top middle screen. And if you save this, everything starts to be enabled and automated in the backend after you saved it. With that, let me hand it over to my colleagues Nikhil, Mostafa, Venkat, and Hannes with new features in the data integration area.
So currently, when we do a replication flow, we had two options. One was initial only, and one was initial plus delta. And a lot of the customers who generally learn BW system or any other ETL tool, they would like to not do like initial load. So if you're doing like a larger load with AC Doka as an example, then it, let's say, has million records. So you do not want to do like a million records every day. You only want to do the delta records, which are generated by the user. So this particular feature would allow you to just pick out those delta records without doing the initial load. So here I just added HANA Cloud as my source connection. I selected the container DB admin and I added product as my source object. And I selected Delta only as my load type. And now I'll be adding my target container as GCS here. Now I'm renaming the target object. Okay. So this should also show you a warning message that Delta only load type will consider the next changes that would be made. So it will not consider the initial load. So let me also showcase here. So this is my HANA Cloud environment. And this is my source table, which is the products, which has 20 columns. And I'll just do a select statement. So you should see 35 rows for this particular table. And let's go back here for a second. And let me set the This will probably take like a few seconds to deploy. Okay, let's go here. It's already deployed. Let's see what's the delta load interval for this one. Just a second. Okay, so here we can see that the number of initial load operations are zero at the moment. And the reason it is zero is because we are not loading any initial load here. Okay, I'll just refresh it one more time. Okay, let me go back to matrix. Yep, the run is complete. And the next run would start after an hour. Yep, it will start after an hour. And you can see the next delta load time here.
Now we have a new task type in the task chain, which is the notification task. And now that offers the ability to be able to drag and drop an email notification task as an object to be running as part of a task chain. So I can also show that really quickly. You see here, I already have a task chain, and we can imagine, for example, I would like to be notified after some parts of it are finished, and therefore you can immediately see here that now we have a new icon here, which is the notification task icon. And by pressing on it, then I can drag and drop it within the task chain. So I can, for example, choose to put it here. And that means that whenever now we reach that point, an email notification will be sent. And it is important as well to mention that the email subject and body are changeable, like we have them for the task chain notification. And for the moment, the mailing list is actually inherited from the task chain mailing list. In the future, we work on improving that to have an own mailing list for each notification task with the option to inherit as well from the task chain.
SAP Signavio is target and replication flows. We have introduced a new connection type SAP Signavio, and you can use Signavio as a target for the replication flows. This enables us to move the data directly from SAP source systems like S4HANA ECC into SAP Signavio, supporting process mining and analytics use case. So before you set up a connection for the Signavio, you would need, you have some prerequisites that you need to do. You need to create a OAuth 2.0 client with technical user purpose and assign a scoped integrator role based on the DW integrator template. So how do you do that? You can go into the Datasphere and go to the app integrator and create a OAuth client. When you create a OAuth client, you would select the purpose as a technical user and select the role as DW scope integrator role. And then you need to copy the secret key and the OAuth client because these two are required when you are establishing one-to-one mapping between SAP Datasphere tenant and Signavio tenant. So when you're using several connections in different spaces, all connections must be mapping to the same Signavio endpoint. So now you go into the Signavio, you need to create a connection to establish this one-to-one mapping using this OAuth client. So how do you do that? You can create a connection, and when you create a connection, you would select a connection type as SAP Datasphere replication flow in the Signavio side, and whatever the OAuth client you have it here in the Datasphere, you would copy that into the Signavio side, and the client secret, whatever you have it, you would also copy that here. And the service route would be your Datasphere HTTPS route, URL route, and the OAuth access token would be from the app integrator. In the Datasphere app integrator from the OAuth clients, there is for each Datasphere tenant, there is a token URL. You need to copy that token URL and paste it here. Once you create it, the connection should show as a valid, meaning that handshake between the Datasphere and Signavio has happened, and the connection is valid between both the instances. Now you can go and create a connection by providing the URL to the Signavio, and then you can create a replication flow and select the Signavio as a target. For the load types, we support initial load and initial and delta. And the business value for supporting this is now you can replicate the business process data running on SAP ERP systems into the Signavio. So let me quickly show you how you set up this connection. So the first step is, before you set up a connection here, you would need to define the OAuth client. That can be done from the administrator in the Datasphere, and go to the app integration. In the app integration, you can create a OAuth client. So in this case, I created a OAuth client here. So in the OAuth client, you would just give a name for your client, and you will provide a user ID for this client, and you select the role. So the scope, you need to select the DW scoped integrator role, and then you need to copy this client secret and this client ID. You need these two when you define the connection on the Signavio side. Now coming to the Signavio side, you would need to go into the process intelligence. Under this process intelligence, you will go to the connections tab. In the connections tab, you would need to create this connection here. When you create a connection, you select the connection type as Datasphere replication flow and give a name to the connection, and this would be the client ID, whatever you define. In this case, when I define the client, this is my client ID. I would choose that client ID here. I would choose that client ID here, and the client secret, whatever the client secret you copied here, you need to provide the client secret, and the service root URL is your Datasphere URL up to the root. So you need to provide that your service root URL, and the OAuth access token URL. Again, you can get that from the app integration. At the top, you will see the token URL for each of the Datasphere tenant. You can copy this URL and paste it here and create a connection. Once you create a connection, the connection appears as a valid. So this is the connection that I created. So once you see this as a valid, meaning that it has the handshake between the Datasphere tenant and Signavio tenant has happened, and the connection is valid. Now you can go back to Datasphere and create a Signavio connection. So we already have a Signavio end-to-end demo. So this is just a interactive demo. I'm just walking you through these different steps. You go to the data builder and you select a new replication flow. In this case, I'm selecting a source from SLT server to extract the tables from SAP ECC system. So select a source container. So within this particular SLT folder, I'm selecting some source objects. So I'm selecting this DDL02L SAP table to replicate the data into the Signavio. And you select the target connection. That target connection would be the Signavio connection that we created. So once you select the target connection, we support initial only and initial and delta. Select one of these options. Once you select these options, you can, if you're selecting initial and delta, you can choose your delta load interval. And once it is done, if you want to add any filters, projections, and mappings, change any mappings, you can do that within the settings, projections and settings. Once that is done, you save the replication flow and deploy the replication flow. So I will end the demo here.
The first story I have is for transformation flow in HANA. So when you had large data volumes to process in transformation flows, there were some cases where they ran out of memory without an option to kind of like reduce the memory footprint. So what we have introduced is a feature which we call batch processing, so that instead of having a monolithic block basically and everything being processed together inside of HANA, we are now running a pre-query and cutting the number of records that you have into batches, and then are processing those batches individually in order to reduce the footprint. So that if you have very large joins, for example, you can do this in order to just stay inside of your memory limits of your workload classes. And you can actually do this separately for initial loads and for delta loads. So sometimes it's only relevant if you reload a very large data set, and so the batch query is only done, or the batching is only done when you do it on the initial loads and not done for the delta loads, because you know the delta loads are only within your queries. Since the batching requires the pre-query and obviously therefore has a little bit of an extra workload that needs to be done. And how you're doing it is fairly simple. It is part of the runtime settings. And as it's part of the runtime settings, it's in the data integration monitor. And if you go into a transformation flow, so I have here a large transformation flow. And if we're going into that, we have basically an additional settings tab down here. Besides where the logs are, you have now the batches. You see I have no batches defined, so it would always process everything as a single batch. And if you define batches, you can pick a column basically that you want to use. Not all columns are suitable, so very large binary columns, for example, are not very suitable. We need columns that we can then build ranges out of, but those ranges are built through the pre-query, and then you just say how many records you want to have in your batch, and then we will kind of like distribute it along these batches in order to reduce the memory footprint. And with this little switch here, you can then turn it on whether it happens only in initial loading or whether it happens for initial and delta loads that you want to set. And that's just about that it to it. So now if you have done that, you can see it. You can always delete it and edit it. Now it will be taken on every run, as it's a very large transformation flow here with many records. I'm not going to run this because it's going to take forever. But basically, it's a simple way of reducing the memory footprint.
With this user story, we added the ability to determine the records which are processed in a batch inside of Python operators of the Spark transformation flows. Before this story, the Spark decided how to batch the entire operation. So it decided basically how many records in a data frame would be passed on into the Spark operator so that they could process. And that was often driven along the partition files or the part files in the source object. With this new feature, you have now the ability to decide based on which columns we want to determine batches. And it's kind of like semantic grouping in BW earlier. But if you select, for example, a material from the source columns, it will make sure that all records of a single material are within one batch. And that allows you or guarantees you that you have all records available you need for a certain operation. So if you have operations where you want, for example, have header lines and you have item lines, and you need to do some kind of figuring out if all items are shipped, or you want to aggregate the items up, these types of operations where you need to be sure that you have everything within your Python that belongs to a header, you can do this by selecting the header, and then you're making sure basically that every row that contains the same header is within one batch, and then the system will distribute this accordingly. I have prepared a little demo for this, so I have created a transformation flow based on material plant. and I have multiple inputs here, and I basically want to count how many plants basically we have for certain materials and how many plants there are in. So I wrote a little simple Python script that is not fully correct because it ignores the versions. But other than that, basically it does a certain count. But this obviously would only work if within the data frame that is incoming, the data frame, I have all plants belonging to a material. So in order to guarantee this, I switched the input mode from system managed to user defined batches, and I selected the material plant column to be my batch column, and that now determines what is put into one batch so that I can then count, basically return the number and store it in a target table. That's the idea behind it, to guarantee you that you have everything that belongs for one material combination in one batch. Now, it takes a little time to run because I have a few more records in here, but I ran this already. So if we're looking at the run status, I can see that it ran actually successfully. I have 1,000,000 records in here, and it ran those successfully. I see actually my largest batch size is 50. And I did run this without batching, and then I actually did have the error that I was expecting, that because my table only contains material plant as primary key, and I had it distributed along two batches, the same material, that resulted in multiple records for material plant. So I had duplicate records, and this is basically what I can see here, that mod plant contains duplicate data. And I can prevent this, and I can make sure that my calculations are better and I'm not getting multiple results with the same key by using the batching. We added in multiple user stories parameter support to transformation flow and task chains. You might be familiar with input parameter support in views, which now came also to transformation flows in a similar fashion and capability. And the task chains learned to call transformation flows by passing on parameters from the task chains, and task chains can pass parameters between task chains so that you can have nested task chains which receive the parameter from outer task chains. Let's dive right into it. If you create a transformation flow, you have now here the section in the properties box where you can create input parameters, and I will create something like a simulated text rate or so in order to maybe simulate what effect a change in the text rate would have on my numbers. I'll make it a decimal. You can give it default values if you like. This is now available, and if I create here a view transformation, for example, and I would pull in the sales order items, for example, I can now use this as I can use it in views. For example, I can use it in calculations by either just creating a calculated column that text rate, that's just the decimal. So here I'm just going to fill in the value itself. It shows up under the parameter tab. Very simple. Validate. And maybe I'll just calculate the net amount times, what is that? Do we want to calculate the gross amount? Then we calculate 1 plus tax amount divided by 100. Then I get my simulated gross amount as a decimal. I'm not 100% sure it's fully correct, but for the purpose of this explanation of how they work, it doesn't really matter. So I have now used my input parameter that has default values on the task chain level inside of the transformation. And I'm just going to write it on a new table. And I'm going to run and deploy this. This is a TRF. And that allows me now to run the transformation with, if I don't pass anything, the default parameter, or if I want to override it, I can do this. And this will show up in the manual execution as well as in the task chain execution. That means as soon as it is deployed, I can run it. I did have already one created so that I don't have to wait for the deployment. Oh, the deployment is actually finished. Good. And let's go immediately back in. So if I run it, it will ask me for the value and fills it with a default value, and I can now execute it with a value that I would like to have it. So if I want to raise the tax to 22, for example, I can do so. That is the portion of input parameters in transformation flows. The other coin to the story, or the other side of the coin to the story, is in task chains. That means I can go in and take my newly created transformation flow, add it as task, and now it will ask me similarly with what value do I want to execute the task. And now this task chain determines basically the input parameter value and passes the input parameter value to the respective job basically as during the runtime. The second option we can this task chain which I have just created, I can create input parameters for this task chain. That means I can create a parameter called global tax here. Again, give it a default value. And now instead of defining a value which I would like to use as input parameter for my child task chain, I can now say I want to map it to an input parameter I have on my task chain itself. So now the value actually does not come from the node, because if I would take two task chains, I can, and let me do this, I add a second task chain that has also parameter, I can set values, right? But if I set separate values, then I would have separate, every child task chain would be executed with a separate value. By using the mapping function or the map2 function to a global tax as a value, I can go in and make sure that every child task chain is executed with the same parameter. Now they both receive the value from the input parameter of the task chain that is then in turn passed down into the child task chain. So you have the options to write values in each of the separate tasks as kind of like a task parameter, or take the value from the task chain. And now it would work similarly if we save and deploy this task chain, and I would create a meta chain around this. Then again, this would understand that my child task chain has an input parameter, and I can fill that input parameter, and that input parameter would then move from the meta chain to the child task chains to the tasks. If I do so, so let's go back here, create another task chain. Meta chain, and let's add the type. And again, it asks me for the value. And so you can basically now define another value, and this one would then be passed down all the way down to the task itself of the transformation flows, and then respectively into the view transformations where it's then applied as we have designed it. With this user story, we added the deletion feature to the local table on files. We were missing that before. We had the selective delete on the HANA records. Now we also made them available on the object store tables. So it's basically closing the gap we had to HANA beforehand. How does that look like? I can go in from the data integration monitor in an object store space, and when I select a table, I have now the ability to delete records directly, and then I have the choice between all filtered records based on a filter that I can define, or even multiple ones if I want to, or previous versions. This is the vacuum options, which we had before. But this filter records is now the new part where you can delete filter-based records. The same function is also available as schedule, and we currently see there is no schedule in here defined, but I can define a schedule, and I can define 3 schedules, obviously, for merge, optimize, and now for deletion as well. And for the deletion, again, I have the same option to choose a filter record. I can give it a name if I want to have multiple schedules with multiple or different filters selected. So I can do all kinds of different schedules to do the operations. Also, I have the ability to choose, again, my applications, when they run and when they should run. And then I can create those schedules normally as it works, but I cannot, as I said, what's different is I can create multiple schedules. So if I want to delete the years, for example, of 24 and 25 separately, or I have like a weekly or a daily schedule, I can do this now by creating multiple schedules, give them names so that I can identify them later, and I'll just use the same time, and it will show up basically under these names, and it will then run the selective delete against the local table files.
Thank you, colleagues, and over to the modeling and consumption area to Jan, Abdul, and Fenya.
With Wave 19, we started to support something that especially the finance community has long asked for, and that is the support of so-called fiscal calendars. And for that, you need to know that companies usually don't use the standard calendar that we all know for the reporting, but they revert to something that is known as fiscal calendars. And for that, they might want to shift their fiscal year. So Microsoft reports from July to June, for example, and many other customers do the same. Many use sort of certain week patterns, like here it's 5-4-4, so January is 5 weeks long, then 4 weeks, then 4 weeks, and together that's a quarter of 13 weeks. 13 periods of 4 weeks is happening often, or special periods, especially for year-end closing, and many, many other examples. So there are so-called fiscal year variants that define how your company is reporting things. And so it's not enough to know that a booking happened on January 1, but that is assigned to a fiscal period. And in order to report fiscal data properly, or along the fiscal calendar, we in Datasphere need to understand what a fiscal dimension is. And this is what we just learned. So a fiscal dimension is a special subtype of a dimension that has a certain properties of its own, so certain semantics, certain validations that this semantics is correct and complete, and certain settings that need to be set. So if that fiscal dimension is then used in an analytic model, and the analytic model detects that, then the analytic model will react in a very well-defined way, and it will mainly ensure that the fiscal year variant is fixed. And that is fixed by virtue of a new variable that is introduced and that you need to set to what your company uses. Companies typically use only really one fiscal year variant. And then SAC does, as it's already been doing so internally for other models, and so it leverages these fiscal dimensions, also for Datasphere data, and so it uses its dynamic time selection, time-based variance, fiscal period shifts. All of that has been supported by SAC before, and now it's also supported together with Datasphere. Now let's look what this is like in the system. So here we are looking at and here you see it, a fiscal dimension. And this fiscal dimension, for that, in order to understand this better, possibly we quickly look at the data. And here I've filtered on one dedicated fiscal year, K3, that we'll later also use in the SAC demo, and on a special fiscal year. And so here you see, for example, that there are additional periods, like beyond December, that are marked as special periods. So this is what I mentioned with year-end closing. So this is something that your financial statements can totally revert to, and will do so in the fact. And so in order to make sense of all of these, a special set of semantics has been introduced, and all of these semantics need to be along. So on the one hand side, you want to have a hierarchy, and we'll see that. You want to define which of the many columns is your fiscal year variant, your fiscal year, your fiscal period. And then this fiscal period goes, in terms of the standard calendar, from a certain date to a certain date. And all of this needs to be pointed out. So if I then undo certain of these things, like the fiscal year variant is not a key, then I have corresponding validations that all of this is correct. So there you're guided through. And then also there needs to be at least one hierarchy along here. You can have associations to a text for your respective fiscal year period. And so these periods come under names like special period also. So if you then have your booking statements, and here we are looking at a fact, and that fact makes in its facts, makes use of that fiscal dimension that it links out to. And if we now look at data for this fiscal period, for example, does in the period K3, let's filter that again. So it contains fiscal year period. So there are certain bookings that are happening also and that are happening in those special periods. And so if I now go and create an analytic model from this, the analytic model detects that I'm using a fiscal dimension in my model. And because of that, it reacts in one particular way, in that it generates a standard variable for this. By default, this is hidden. Normally, you wouldn't prompt your users for your fiscal year variant. Nobody would normally know what this means. So it's totally legit to fix that. In our case, this example company is fixing this on K3. And so I just generated a new model. I did the same ahead of time for this one. So this is exactly the same model. It now limits itself to one measure and has the fiscal year variant fixed to that K3 value. And if I now go to SAC and build a story on this, then this story is totally aware of the existence of special periods. And so if I drill, so in this case, very often the special periods are booking and back bookings. So it's really balancing statements. And so this sums up to 0. And if you now, for example, go here and look at this, then you can use, for example, dedicated filters for your period. So here you might want to filter by range. And again, here you are in a dynamic or fixed manner, making use of those fiscal periods or fiscal year periods. So if I would fix myself on the fiscal year period and look back 20 and look at 3, then this would be from May 2024 to the special period that is yet upcoming. So SAC is totally aware of these periods. And by the same token, if, for example, here I filtered on fiscal year periods, then these, we had this for 2020, these periods are totally known to the system and valid for reporting. Actually, the texts that I had reference to for the from the fiscal dimensions, this is what is shown here. And so SAC totally knows what the fiscal dimension is end-to-end and offers its way to handle this in a dynamic or fixed fashion. And yeah, this is financial reporting with SAC on Datasphere with fiscal dimensions. With Wave 20, we've introduced something that many of you have long been waiting for, and that is the multi-structure query support readily integrated into the analytic model. So what is that? So this is an integration feature between SAC and analytic models that many of you may know from SAP BW, and that defines a structure, and in a way it's an own dimension with a set of members. And if taken into drill, those members are then applied to all the measures. This might sound opaque, or we'll come to that. So what these members are essentially either calculations or restrictions, and that you define generically. So you would define a restriction on a country, on your top customers, on your top customer segment or so. And you can build a whole plethora of these and also referencing each other. And then you can throw them at all the measures currently in drill. And that becomes a bit clearer when you look at the right screenshot here, that there are a couple of measures currently drill: hours worked, month salary, bonus, and hourly wage. And now, rather than defining restrictions individually per measures, like the hours worked in Europe, the hours worked in a reference country that I get from a variable or so, I build a whole list of those that I want to use in different contexts. So I have my list of top customers, and now my top customers, I wonder how much value I sold, how much quantity I sold, how much margin I made also at the same time. And so this is super helpful to centrally define these and then reuse them in different contexts. And SAC can then go along and use those and either select them, a subset of them, all of them, or even define own members. And SAC has had their cross calculation that they recently renamed to structures, and now that basis of the structure can totally come from an analytic model. This is the innovation, and there are a couple of sub aspects around this, and possibly we first look at the feature and then we'll come to those in a second. So when we look at the system, it's a normal standard analytic model with a couple of measures defined, its dimensions, and there's now a new area, the structure members. And in there you define either calculated or restricted structure members. And I've already done so. So here, for example, I've defined what Team Europe is. And Team Europe doesn't make reference to any measure, but if there is a measure, then I can apply that restriction in a way on top when taken to the real. So this generic restriction will take the current measure value and restrict it on those countries, Germany, Spain, and Great Britain. And while another such generic restriction might take the input of a variable and use that as a restriction. You can totally use also constant selection as part of this, so that's fully there. But exception aggregation, for example, is not. But let's wait for shortcomings and out-of-scope elements until later. So then, at the same time, you also can define calculations. So you can make reference of other structure members. So we defined what the restriction Team Europe is, we defined what the restriction reference country is, and then we can totally build the sum or or fractions or so. So any normal math calculations or build ratios therein. So I did that. I chose what part of the country I'm currently particularly interested in because I prompt the user for this, and how that relates to the current to the Team Europe. And also there is one generic member that we always sort of auto generate, but that you can totally take out if you feel it's not helpful. That's essentially an empty restriction. So it's a restriction that does nothing, and by not doing anything, the measure value as it comes. So the complete value of the current drill, the complete quantity of the current drill is shown. And that's already it. So if we now go for the preview, and we are prompted with a variable as I designed it. And now I have a couple of measures in my drill, and I might want to take other things into the drill, the current fiscal period, for example. And what I can now do is that I take on top the structure into the drill, and either with some members or all of them, let me start with that. And so I would now see for the fiscal period, first quarter of 2022, I would, if I now hide the lot, see the measure value. So how much and many hours got worked, what is the monthly salary by the people worked, the bonus or the hourly wage. But by the same time, do this for the reference country, for Team Europe, or compare the reference country to Europe. So that's already neat. And so in that sense, the structure really behaves like just another dimension that you can totally use alone or together with others for your drill. If you're not interested in certain ones, you just don't check it, but it's something like a reusable application of a restriction or calculation on top of a measure. And now SAC is totally able to do the same. So if you here have a table, then you can sort of pull in for that table. You can pull in for the table here the structures as an own element, and together with potentially other dimensions. And then if I want to do so, add own structure members. So I'm totally able to define own calculated structure members, own restricted structure members already in this context. So I can totally say, I take whatever measure I come across in my drill, but I want to look at what the continent has in store for me there. So I select that, I do it for North America, and do that. And so I can use the structure as it comes predefined in the analytic model. But if I want more, I can totally define those. And by the same token, I can also, filter out certain members. I now defined, did I define US? I defined Germany, for example, as a member that is not in what the analytic model defined. And so it's now in here, and I toggle it on, sort of not filtering it out, and I'm drilling by this. And the same would work also for other visualizations. If we now come back to the slide, then let's finish the remaining topics. So we covered that there's an all measures value, and that is really helpful because you regularly want to compare a restriction to some all value. So the sales in Europe over the sales over the world, the sales in a specific country, a customer segments as compared to something. So for ratio of countries calculations, it's very handy to have this in store automatically. Structures are just working in the analytic model. And so when you do stacking, those structure members, those structures can totally be used and seen and inherited by the upper analytic model. If you change anything on the life cycle of field they reference or within the structure, the lifecycle management hits and upper init model also are directly affected. Also, when variables are used and variables then get deleted, this is totally detected. Also, dependency graph. We didn't go into this in the demo, but the dependency graph between various members that stack on each other. So the ratio is made up of its numerator and its denominator, so that dependency is totally passable and visualized just by default. We had it that restricted structure members totally support constant selection. SAC stories that already rely on an analytic model just become better if that same analytic model learns a new trick. And so if you now add a structure to that already used analytic model, then that totally works and doesn't affect the SAC story, but that SAC story has now learned a new trick and now can leverage that structure. There's one thing that we possibly briefly need to go into as well, is that potentially if you have two calculations happening at the same time, you need to decide what calculation comes first. So if the measure does a calculation, because it's a calculated measure, and if the member does a calculation, the one is coming from sort of vertically, the other coming horizontally. So what calculation does first? Does the summing first happen and then the division, or first the division and then the summing? So that is important, and that is known as conflicts. And what you can do, and this is what this notch icon here is for, is to define, okay, either it's always the measures winning or it's always the members winning. That is not in line with what BW can do. They can do it more individually in a way per cell. Here in SAC, you can do it. We aligned with the SAC design. And so it's really first either measures win or members win. And so what this is really trying to do is centrally defining definitions and using them wherever. So you have a central definition of what your, in the end model, of which your core customers are, what your top segment is, your top products are, and then you apply this to so many different measures without sort of multiplying them out. The value restricted by 15 different ways, the quantity restricted in 15 different ways, and so on. So this is really just handy for centrally organizing this. At the same time, it needs to be said, this is a catch-up on BW, but this isn't quite what BW does, mainly because we aligned with the SAC structures and their cross calculations and what they can do. And so there's still some way to go for being a full BW query structure replacement. So in BW, you can totally handle individual collisions. This we cannot do. We do it really flat. It's either measure wins or the structure wins. Also, it's possible in BW to define so-called cell-based formulas. So there is individual cells at the intersection. You can totally over-define for that cell what should happen. And this is not possible. Also, exception aggregation, because it can meet with other exception aggregations. It's very hard to define and to understand what really happens in a cell. So we decided to not support this. It's also in BW that structures are a modeling design element in their own right, outside of a query itself, but a query can use it. And this is not the case here. So the analytic model defines a structure. Any structure lives within an analytic model, but it's not that. It can take a structure that was centrally defined and just use that. It's not a modeling entity in its own right. It's a sub-element within an analytic model. So cell calculations we had, and also the hierarchical display of members is nothing we support. It's really a flat list of members that we support. And then I provided a bit of additional reading material for the inclined by SAC on sort of how cross calculations are used, but now they are provided by analytic model in a sort of central fashion. And with that, thanks for watching.
The next one is the unit conversion in the analytic model. So the analytic model introduces a unit conversion measure type to automatically convert the unit to an alternative unit. This is similar to the currency conversion that many of you are familiar with. We use ERP style or global style unit conversion. We basically use T006 star tables, so T006 and T006D, those tables to allow conversions between the units of the same kind. For example, length, meter to kilometer to mile, etc. Right? Or weight, like kilogram, gram, etc. Right? So there are two steps involved. First, you prepare the conversion tables in one of three ways. You can manually create them and maybe prepare the data as well, or you can import it from one of the source systems, S/4HANA or BW, and or you can use somebody else's who was shared from another space. So if somebody is imported into one space and they can share it to another space, and you can use the conversion tables from there as well, right? And note that the source measure has to be a fact source, and the source unit is derived from the unit field that's assigned to the measure in the fact or ADS with a semantic type of quantity with unit. And the target unit can be specified as either a fixed value or a reference to a dimension that's mapped to an attribute of the fact with the semantic type as unit of measure, or you can use a variable to populate the parameters for the target unit, right? Let's look at a demo. We are in the data builder and we prepare and load the unit conversion views here. You can either create them manually, where it will create these three tables and these views, and then you can also share it after they have created them, or you could pick it up from one of the source systems, and that will bring in a replication flow. That's what I'm going to do. I'll hit create, and once the replication flow has been created, I need to deploy that, and that's been deployed. Now you can see all the tables and views with T006 created here. So I'll go ahead and execute this replication flow. That should give me all the data in the conversion tables. I do a preview to ensure that the data is there. I can share the tables to any space that I'm interested in, and then create the views in that particular space so that I can use these unit tables, T006 tables and dimensions there. Now we actually go to use those units that we imported those conversion tables. Now we want to use it in a scenario. I start with an analytic model, and I see that I have a couple of measures. I have defined a conversion measure already here, and you can notice that I have picked the target unit here as an existing source variable. Let me show you that variable, and this is the variable here, and the data type is inherited string, and that is used in the conversion kilogram, right? So we go back there. Let me try to define a few more conversion measures here. Let me pick a target unit here, and in this case, let me pick a dimension. And let the decimal places be 0 in this case, right? Create one more. Call it gram. In this case, we've already picked variable and dimension for the previous two measures. Let me pick fixed and
call it gram. Let the formatting be 3 decimal places. And let's find the last one. Call it milligram. Choose the fixed one there. And in this case, let me pick 0 as the decimal places. Let me preview this model. Let me make some adjustments here. And now we can see that the original dimension that picked up shows the same value as weight. 3 grams is 0.003 kg, which is 3000 milligram, and so on, right?
Hello, Fenya here. As some of you might have noticed, in our OData API rules, we still use the abbreviation DWC, so Data Warehouse Cloud, which is the old product name. And we now transitioned to having our API routes using Datasphere, which is the current product name. So what will happen is that our API routes to the catalog, to the relational consumption and the analytical consumption now have 3 new routes that all include the Datasphere product name. And we will have a transition time that is probably around 18 months, which I think is the SAP standard, before those ones will be deleted. For now, they are deprecated. We have the Business Accelerator hub where all the APIs are listed, where you can type in Datasphere, and then you will find that for consumption, we have the previous path, which is now deprecated, and we have for consumption the new path, which is okay. And the same for catalog here. That's the previous path, which is deprecated, and the new catalog one. Then we have put that into our sub-help documentation, where you will find here also a note that says the former URL with DWC is deprecated and will be discontinued. Now the new URL is Datasphere. And in our analytic model or view, when you create an OData, or when you generate an OData request in our helper tool, we also have here the new one, which is Datasphere. So if you just continue to use that one, there should be no confusion about this. Thank you very much.
Thank you, Jan, Abdul, and Fenya, and over to Getien and Amok for some more user stories.
Hey everyone. So today I'm going to present to you 2 new enhancements request features that we have for the catalog in SAP Datasphere. So the first one is related to our support of the lineage for SAP Analytics Cloud Insights that are based on Datasphere models. So basically, we were not able to have a look at the lineage or impact between SAP Analytics Cloud Insights and Datasphere models when these SAP Analytics Cloud Insights were based on these SAP Datasphere models, preventing, for example, use cases such as Datasphere modelers that wanted to perform any changes on their models, and then to see the impact of these changes to the different SAP Analytics Cloud Insights. So this is a customer requirement that we got. And so now you are able to directly go into SAP Datasphere and the catalog and have a look at either a model or an SAP Analytics Cloud Insight and see the lineage or the impact analysis when relevant. So that's really help primarily to evaluate the impact of now updating or changing any SAP Datasphere analytic models and to see which SAP Analytics Cloud Insight that would be based on this model would be impacted with. That also help to explore the lineage of SAP Analytics Cloud Insight to know from which model they are based on. So data discoverability are also the different use cases that you can do. The second enhancement that we did is the ability to support either KPI or glossary term import directly in the catalog. So as you know, the catalog offers the ability to create glossaries and terms associated to these glossaries. You could also create KPIs, and these glossary terms or KPIs, they can be used in order to enrich the metadata of the different assets that you have in the catalog. They can be directly linked with the assets, or they could be linked with the attributes as part of any of the assets that you have in the catalog. So the feature here that we have is the opportunity now to import either KPIs or glossary terms from an Excel file, a flat file, and then using mappings to links, columns to the attributes that will then form the KPIs or terms with their respective custom attributes. The file formats support various standard, I would say, SAP file format export for the terms. So, for example, this is also compatible with the SAP Information Steward term export file. So that would allow, for example, use cases where you would open SAP Information Steward and then you would export the list of terms that you already defined there, and then you can re-import these terms directly into SAP Datasphere. So that's really giving you the opportunity to reuse existing and approved terms, same for KPIs, and allowing you to jumpstart using terms and KPIs directly in SAP Datasphere without the need to recreate them, but reuse what you already defined in other SAP application, for example, SAP Information Steward. So for that, well, let's have a quick look at how this is created in a very short demo. So in the catalog, you can directly go and import either KPIs or terms, and you will have, for example, for the terms to select the glossary. Okay, so then once you selected the glossary where you want to import the term, you can directly select the Excel file that you are interested in. Once you are in the once you selected the Excel file, you can easily select which terms you want to import, use various controls to list the separators, and define the list of hierarchies that you would like to use in order to define and map the different attributes that are within your Excel file to the attributes that are available with your glossary. So it's really mapping the glossary template and the glossary definition to the definition of the content of your flat file. And then once you're done with defining the different mappings for the attributes, the numbers and strings, you can directly import them and then see that it's completed.
Okay, and the next one is a very interesting one, and I'm pretty sure that a lot of you might have been waiting for this. A lot of discussions would have happened. So some time back, we moved the workload management from within a space to a central location in the configuration, and there we could see a list of all the spaces and the priorities that they have, and the configuration, the workload configuration for each of those spaces. Now, when I had demoed that particular change in this round here, I had mentioned that it was only a foundation for what is to come next. And now I'm here with the next feature that actually makes use of that foundation. So first of all, why do we need resource assignment on workload group level instead of a space level? So today, everything that you do from a workload configuration perspective by default is on a space level. which means that each space is a workload class and that each workload class gets its own resources. And what you could do today as an administrator, I mean, before the release of this feature as an administrator was decide which space can use up to what total statement thread limit and total statement memory limit, and what could be the priority of each space. But as soon as you have multiple spaces doing the same thing, there was no cap on the activity that was being performed. And as such, what could happen is that there could be multiple spaces that are doing data management tasks and are consuming all the resources in the tenant, which meant that the the consumption activities were left with no resources. And this was a very common problem that was identified between customers, where they said we really want to keep a cap, a limit on what an activity can consume and not what a space can consume. So the space level resource allocation is something that is valid, but does not hold true for all the use cases or all the landscapes for every customer. Some customers still wanted to do it by spaces, where they somehow felt that keeping a cap on each space made a lot of sense for them because they could actually control what each space could consume. But for other customers, it was always the type or the activity that was being performed that was to be controlled. And the reason behind that could be that you want your tenant to be serving more consumption requests than your data management activities, because as such your consumption activities are more critical, because otherwise your dashboards would not work, and so on and so forth. There was one additional problem that we had identified, was that you had your database users that were created per space, and there was no way to limit the consumption of resources that were done by these database users. But as such, customers that were exposing their data set for SQL consumption wanted to also keep a limit on how much can be consumed through this SQL endpoints. And now with workload groups, we have now created such a mechanism where uh, the resource allocation can be changed from a space to a logical group. Why am I calling a logical group? Because as soon as you select these groups, there are 8 categories which are going to be leveraged, and you can decide the priority for each of these categories along with the configuration for the total statement thread limit and total statement memory limit. The configuration comes by default, obviously, but you can also change it with respect to what is the percentage that is to be leveraged by each of these groups. What you can then achieve is you can decide whether a certain group has a higher priority and a certain group has a lower priority. Now, all these spaces that are doing that particular action, when I say, for example, consumption, if all the spaces are doing a consumption action all together at the same time in parallel, the system would limit the overall consumption activities with respect to the logical groups that you're doing. So you can then decide on your tenant whether consumption can consume more than 50% of your resources, or let's say less than 70% of your resources only, so on and so forth. So let's try to look at that in the system, which gives you a bit more idea of what I'm talking about. So again, I'm back in configuration, but this time I'm going to go in workload management. Let me first change it to spaces so that I reset it back to where it was previously. Bear with me for a few seconds. So now all these spaces that you see here, I can actually select any of those spaces, and then I select what is the total statement thread limit and memory limit, and I can save it. So now what happens is that my space can consume up to 70% of the total statement thread limit and 80% of the total statement memory limit. Mind you that this is still the limits come out of whatever is allowed for customer processing. So there is still a higher cap that is set to 80%, where 80% of the overall tenant resources can be used for customer actions. and 20% is reserved for all internal actions, heartbeats. Then it could be background actions, it could be the analysis user, all of that. So all internal actions, all administrative actions that are required or necessary to keep the system up and running are then categorized in those internal actions. But whatever you can do as customers is then 100% for when considering each space. So this could be 80% of 80%. You can think of it like that. But what used to happen was that if I then change the configuration for this space as well and set it to 70%, what it meant was that these two spaces, both doing data management actions, could consume almost all of the resources that are available for customer actions. And if a third space is trying to do SAC consumption, it would not get resources because the resources were then used by these two spaces, for example. And as such, customers were wanting to cut this not by spaces, but cut it by logical groups. So now you could actually select groups and click on save. It tells you that you can actually take a backup of whatever you have. So you can also, using these buttons, export and import configurations. I won't want to do that because I've already done so. And I can choose to cut the resources by groups instead of spaces. And now what happens is I get a list of these groups that are coming out of the box. At the moment, there is no possibility to create additional groups or to map the way that you would possibly also do on a HANA level. But we are trying to create groups based on our understanding of how different technical users could be mapped. So all the analytical model preview, all the SAC consumption, all the OData consumption is grouped under analytic consumption logical group. All the data integration actions like running task chains, data persistence, or importing data wherever HANA resources are required would be grouped under data management. Whenever you have data preview actions that are happening either in a data builder or in a business builder are grouped in modeling. Then all the data export and import in SSC is grouped under SSC data management. We require the SSC groups to make sure that all the planning activities can go through. So interactive operations would then be the loading of stories that is done from SSC perspective. Long running actions are planning actions that are going to be working, for example, planning workflows. System operations is then going to be used by SSC for collecting stats or for performing cleanup jobs. And SQL access mainly is the usage of resources from a SQL database user perspective. Now, I can, as an administrator, I can set the priority for each of these, and I can decide whether a particular particular group gets a higher priority, for example, analytics consumption. And I can also set the total statement thread limit and memory limit for a particular logical group. Now, when I do that, all these spaces in the tenant, all of them doing analytics consumption, whether it is one space or whether it is hundreds of spaces, all of them cannot consume more than 80% of the total statement memory limit. 80% of whatever is allowed on the tenant. So what we are trying to do this way is that we can actually decide that I want only 50% to be used by analytics consumption and 50% to be used by, for example, to be used by data management. So if at all there is a point in time where there's a high analytic consumption and there are a lot of data integration tasks that are running, they could consume 100% of what is available to the customer, but each of them would be then capped to a certain limit through the usage of logical groups, so on and so forth. This is done to ensure that the overall limit is enforced on an activity level and not on individual space level, right? As such, the workload groups in the background would also be enhanced with this. The mappings of the workload classes would also be changed every time that you are changing it between spaces and groups, and then it takes effect. You can check that using the analysis user to look at the workload configurations in the background. For this tenant, I'm still going to revert it back to spaces, because this is exactly how we want it to be. So at the moment, what we have tried to do is that every action that is performed in the tenant is grouped to one or the other logical groups. If it is a customer action, and if it is not a customer action, if it is an internal action, it will be grouped under the internal bucket. So the overall limit of 20 and 80 that I had mentioned, it will fall in those internal. So there's a case where each action that is performed is mapped in either one of these logical groups, or if not, then the internal group. If there is any action that is not mapped, I mean, if we have not covered any of that, this is something that will then be covered in the follow-up user stories. But so far, we have mapped all the technical users and all the technical actions.
Thank you, Amok and Getya. And now let's have an outlook. So on the topics we plan to deliver end of the year and also next year. If we look at Q4, we plan to offer a public API for triggering task chains from outside of Datasphere, but also on the OpenSQL schema side, a certificate-based authentication mechanism. On the task chain part, we will introduce error ports so that you can decide what happens on error or success of a particular task within a task chain. Also on the replication flow side, we plan to introduce a new source with Oracle. Looking at modeling, the major new feature planned for Q4 is sharing of analytic models together with its contributing entities like facts, dimension hierarchies, etc. to other spaces. And then on the SAC side, there's a big one with the scheduling of an SAC story based on a live Datasphere connection. On the catalog side, we're enriching data products with catalog metadata and support metadata extraction also for replication flows as a next step on enhancing the metadata artifacts within the catalog. Semantic onboarding for HANA Cloud calculation use is planned. And then looking into next year already, we are planning on replicating from object store sources in Parquet format, right? In addition to what's currently supported, and also then adding a new target with Microsoft SQL Server into replication flows and being able to support the cloud connector for cloud data as well as cloud object stores. On the modeling side, we plan on allowing restricted measures in analytic models that restrict on a node of a hierarchy in Q1, as well as the support for display attributes in analytic models. And if we look a little further into Q2 and beyond that, what we have planned there is business functions for time period calculations in analytic models, as well as analytic models supporting multi-fact modeling. On the integration, data integration, scheduling side, we plan on introducing the handling of schedules upon user deletion. And on the catalog side here, expanding the crawling reach to HANA Cloud as well as S4HANA and SAP ECC within the next year. And then on the integration of user and authorization management, we plan to also add events or these kind of events into the audit log, right? So to enhance that capability. And what we also plan is introducing the concept of namespaces and sharing of dependent entities within the modeling area. And then, like we did pretty much every quarter, we added additional data centers, so additional regions within existing hyperscalers like Google Cloud Platform, Microsoft Azure, and we also plan to expand that into the sub-infrastructure provided cloud data centers. So that brings us to the end of the session. So I thank all of our speakers for preparing the great content of the session today, and thank you for being here with us, and see you next time around. Take care and see you soon.